Today we're going to talk about parabolas in a different form. So if you notice in the past, we've been doing a lot of parabolas in vertex form. Today we're going to look at parabolas in this form. We know it's a parabola because it still has an x squared in it. It's just going to look a little bit different form at the beginning. So if you flip your page, we're first going to start by writing down what form this is. This form is called standard form. So under standard form, I want you to write f of x equals ax squared plus bx plus c. And you're used to seeing standard form as highest power to lowest, and that also holds true for the standard form of parabolas. So now, when we had vertex form, it was really easy to get the vertex. It's a little bit more work when we are in standard form. So the two steps of getting the vertex in standard form is the first step is to use this formula, negative b over 2a. And what that gives you is the x value of your vertex. And then what you do for your second step is you plug it in for x, and that gives you your y value of your vertex. So we'll do a whole bunch of examples that kind of explain this. But this formula right here is a formula you'll have to memorize. So whenever it's in standard form, the way we get the vertex is we always start with this. So let's take a look at our first example. It says find the axis of symmetry and the vertex. So I'm just going to write axis of symmetry and vertex off to the side. All right, so here's what we do first. We use this formula. So if you notice, the a value of a parabola is always the number in front of the x squared, the b is always the number in front of the x, and the c is always your constant. So in this case, we take the opposite of the b. So the opposite of negative 10 is positive 10. And I put it over 2 times the number in front of the x squared, which is my a. So my a is the number in front of the x squared. So in this case, because there's not a number there, my number is going to be 1. So then I have 10 divided by 2, which is 5. So in this case, my vertex is 5 something. Once I get that vertex, I can then write down my axis of symmetry, because your axis of symmetry is always x equals the x value of my vertex. And then to get the y value, I take this 5 and I plug it in the equation. So you could plug it in your head. 5 squared is 25. Negative 10 times 5 is that minus 50 plus 2. And if I add all 3 of those together, I get the value of negative 23. If that's hard for you, you could have also gotten your calculator out and you could have plugged it in there. Just make sure when you plug this value in, you put it in for the variable in parentheses. So I have negative 5 squared minus 10 times 5 plus 2, and I get my value of negative 23. So my axis of symmetry is x equals 5. My vertex is 5, negative 23. Let's try another one. I again need my axis of symmetry and my vertex. So I start with negative b over 2a. So the opposite of b here is going to be the opposite of 16, which is negative 16. And then I have 2 times my a, and my a is negative 4. So that becomes negative 16 over negative 8, or the number 2. So my vertex is going to be 2 something, and my axis of symmetry is going to be x equals 2. I'll show you again how to plug it in on your calculator. So you go negative 4, parentheses, 2 parentheses squared, plus 16 parentheses 2. So my vertex is going to be 216. Let's try another one. I again need my axis of symmetry and my vertex. So I'm going to go the opposite of b over 2a. So the opposite of b is positive 8. Over 2 times my a, which is a negative 2. So I have 8 over negative 4, so my vertex is negative 2 something. My axis of symmetry is then x equals negative 2, and then I will plug it in my calculator. So I go negative 2, parentheses, negative 2, parentheses squared, minus 8, parentheses, negative 2, plus 5. And I get my y value to be 13. Let's try the next one. I again need an axis of symmetry and a vertex. So I'm again going to use my formula. So the opposite of b is negative 6, and then 2 times my a, which is a -3. -6 divided by -6, my vertex is 1. Once I know my vertex is 1, my axis of symmetry is x equals 1, and I just take and I plug in that 1. And again, you can punch this on your calculator. You could also plug it in on your head, and it looks like my y value will be 4. All right, so now what we're going to do is we're going to graph functions and find the domain and range. So we're going to first do this maybe by finding the vertex point. So if you take a look here, I would take the opposite of b over 2 times a, and it looks to me like my vertex is going to be -1 something. And you can use your calculator to figure out a lot of this information. So if I punch out 3x squared plus 6x plus 2, and I hit graph, all right, there's my parabola. If I go to my table, I can actually get this value at -1 without having to plug it in. So that's another way of getting your value at your y value of your vertex. So at -1, it's -1. And then not only am I going to graph that point, but I'm then going to graph a point above and below. So 0 is at 2, and -2 is at 2, and all of a sudden you have a very nice, beautiful graph. Once you have your graph and your vertex, okay, that vertex point was -1, -1, your domain will always be reals, and your range always deals with the y value of your vertex. Because it goes up and gets bigger, it will be greater than or equal to. So let's try another example. So the opposite of b will be +8 over 2 times 2. 8 over 4 is 2. So my vertex is going to be 2 something. So I'm going to plug this in here, and I'm going to plug in 2x squared minus 8x minus 1, and I'm going to hit graph. There's my picture. I'm going to go to my table, second graph, and I'm going to go to the value of 2, and my vertex is at 2, -9. So I'm going to put a coordinate or a dot at 2, -9, and then I'm going to graph a point above and below. So at 3, it's at -7, and at 1, it's at -7, and I'm going to draw my nice, beautiful graph. Once I get my graph, my domain is all reals, and my range deals with the y value of my vertex, which is -9. Because it gets higher, it'll be greater than or equal to. On my last example, I take the opposite of b, which is 1, and then it's 2 times a, which is -1/5. So I have 1 on top. When I multiply 2 times -1/5, I get -2/5. And then I can actually simplify that right on my calculator. I go 1 divided by, parentheses, -2/5, and I get my vertex. So I go to y equals, I put in -1/5 x squared minus x plus 5, and I hit graph. So this time to get my y value, I can't use my table because this is a decimal. However, there is a key. You could either plug it in, or that's probably our easiest way right now. So if I plug it in, I go -1/5 times -2.5 squared minus -2.5 plus 5. And it looks like my y value is 6.25. So -2.5, 6.25 is approximately right there. I'm going to go to my table again. I can't really find -2.5 on here, but I can graph a couple above and below. Do you see how at 0 it's 5? And at -5 it's also at 5. So I can graph those two pretty easily and get the nice rough sketch of my graph. My domain is reals, and my range will be y. My y value is 6.25. Because it goes under, it'll be less than or equal to. All right, if you flip your page, The other thing we're going to do is we're going to talk about max and min. So we talked about that, I think, in lesson 8.1. So max is when there's a high point, and min is when there's a low point. So a max occurs when it opens down, and a min occurs when it opens up. Now, the good part about this is it still deals with the vertex. So anytime they say max or min, you're still dealing with the vertex. So it says, tell whether it has a max or a min, and then find the value. So again, I'm going to use that formula, negative b over 2a, and I'm going to start with number 9. So the first thing I notice is that there's a negative out front, which means it's going to open down. Because it opens down, it's going to have a max. So now I just have to find the max. So I take the opposite of b, which is 5, over 2 times a, which is negative 1/2. 2 times negative 1/2 is a negative 1, so I know this max is going to occur at negative 5 something. I again do what I did on my last page. Negative 1/2 times negative 5 squared minus 5 times negative 5 plus 2, and it looks like the second part of my vertex is 14.5. Let's try another one. On number 10, you will notice because this is positive, it opens up. Because it opens up, it has a min. I'm again going to use this formula. The opposite of b is negative 16 over 2 times a, which is 8. Negative 16 over 16 is a negative 1. So my min is going to occur at negative 1. I'm going to take my calculator. I'm going to go 8 parentheses, negative 1 parentheses squared plus 16 parentheses negative 1 plus 4. Oh, sorry. Minus 2. And it looks to me like my other value is at negative 10. Let's try the next one. This one's going to open down because of the negative out front, so this one's going to have a max. I take the opposite of b, 4, 2 times a, which is negative 1. 4 divided by negative 2 is negative 2. I then plug it in. The way I plug this in is I go negative parentheses, negative 2 parentheses squared, minus 4 parentheses, negative 2, minus 7. And I get my y value to be negative 3. Let's try the next example. Because this is negative, it opens down. Whenever it opens down, it has a max. So in this problem, the opposite of b is negative 7. 2 times a, which is negative 7. I have negative 7 over negative 14, so my point there is going to be 0.5. Then I take and I plug in 0.5. Negative 7 times 0.5 squared plus 7 times 0.5 plus 5, and I'm going to hit equals, and it looks to me like I get 6.75. Try our last two real quick. Because this opens up, it opens up because that 9 is a positive. Because it opens up, it has a min. So I have the opposite of b, which is negative 6, over 2 times 9. Negative 6 over 18 is a negative 1/3. And again, you could have written that as a decimal. So I go 9 parentheses, negative 1/3 squared, plus 6 parentheses, negative 1/3, plus 4, and it looks like my other value is going to be at 3. Last one we're going to do, because this is a negative, it's going to open down. Because it opens down, it's going to have a max. So I take the opposite of b, which is negative 1, over 2 times negative 1/4. And if you can't do some of that multiplication in your head, you can just go 2 times negative 1/4 on your calculator, and you get negative 0.5. Negative 1 divided by negative 0.5 gives me the value of 2, so I'm going to plug in 2. So then I go parentheses, negative 1/4 times 2 squared plus 2 minus 6. And it looks to me like that y value is at negative 5. All right, let's try a couple story problems. So on the first example, it says the function h equals negative 16t squared plus 250t represents the height in feet of a rocket t seconds after it is launched. The rocket explodes at its highest point. So if you think about a rocket versus time, here's the rocket. It shoots up and it comes back down, or it explodes up in the air. And sometimes if it explodes, it could come back down. So let's say this rocket explodes at its highest point. If you notice, that highest point is its max, and it's its vertex. So because it's its vertex, we're going to again use this formula. So I take the opposite of b, which is negative 250, over 2 times a, which is negative 16, and that gives me negative 250 over negative 32. So if I were to punch out negative 250 divided by negative 32, I would get about 7.8. So the coordinate up there is going to be 7.8 something. I'm then going to plug in the 7.8, so I go negative 16 times 7.8 squared plus 250 times 7.8. And I get 976.6. So it says the rocket explodes 7.8 seconds and its height is 976.6 feet. So it says, when does the rocket explode? 7.8 seconds. At what height? 976.6 feet. How long is the rocket in the air? So let's say it didn't explode and it came back down. We're trying to find this. So if I'm trying to find this, my height is 0. The only way you have solved this up to this point has been by factoring. So today we're going to learn a different way of solving it. If you go to your y equals and clear it out, if you put in negative 16x squared plus 250x in your y1, and then in your y2 you put 0, and you hit graph. All right, so here's our first problem. You can't see much of it because our window is crazy. So let's go to our window. Our x is our time. So we want to go when our time is 0, maybe up until, if it gets to its kind of point where it explodes at 8 seconds, let's maybe go 0 to 20. My y's, I'm going to go 0. I know I have to get up to about 1,000 feet. All right, so what we are trying to find, if you notice, my blue line was my negative 16t squared plus 250t. This red line along the bottom was at 0. So I want to find when it's back on the ground right here. So once you have them both graphed, if you go second, trace, or calculate, you go down to number 5, intersect, and hit enter, and you then see this little cursor guy. If you move that cursor guy near this point and go enter, 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 it looks like it lands back on the ground at 15.625 seconds. Okay, let's try another one. All right, so here we go. You're launching a water balloon. Here's my equation where it represents the height after the t seconds it's been launched. So think about a water balloon. Kind of launch it from up in the air. It goes up and it comes back down. All right, first question, what is the height at its highest point? That is again the vertex, and we are again going to use negative b over 2a. So I take the opposite of 80, which is negative 80, over 2 times a, which is negative 16. So I'm going to go negative 80 over negative 32, and I'm going to divide those two. So my x value there is 2.5. I'm then going to plug it in. And it looks like the height is at 105 feet. So at 2.5 seconds, the height is at 105 feet. So that's my answer to part A. Next question says, how long was it in the air? So again, we go to y equals. I'm going to put in this equation, negative 16x squared plus 80x plus 5. And then I'm going to put in 0 here again, and I'm going to hit graph. Oh, even though I can barely see it, I'm still going to get my 0. So I'm going to try and find this point right here where it hits your x-axis. So I go second trace down to number 5. I move my cursor guy. And if you can't see him, if you hit your up and down arrow, it'll help you see him. I get near there, can barely see him on there, and I go enter, enter, enter. And it's going to come back on the ground in 5.1 seconds. And you're always looking for that x value there. Okay, if you flip your page, we're going to do one more problem like that. So here's my equation now. We're going to talk about a beanbag tossed in the air. So think about a beanbag, goes up, comes down. First thing, max height. So I'm then going to get the vertex, and the way I'm going to get the vertex is negative b over 2a. So I take the opposite of 5, which is negative 5, over 2 times a, which is negative 5. Negative 5 over negative 10 is at 0.5. So that vertex is going to occur at 0.5 something. I'm then going to plug it in, clear my screen. So negative 5 times 0.5 squared plus 5 times 0.5 plus 1, and it looks like the beanbag gets 2.25 feet high. So the max height is at 2.25 feet. All right, how long was it in the air? We are again looking for that. So I'm going to go back to y equals. I'm going to put in negative 5x squared plus 5x plus 1. I still have my 0 in. I'm going to get back to a standard window so we can see things a little bit better. So I'm going to go zoom 5. Sorry, I just hit the wrong button. Zoom 6. Hold on a second. Zoom 6. Sorry, there's a standard window. You can see it goes up and it goes down. So we're looking for this point right here where it's back on the ground. So if I go second calculate, there goes my other y equals 0 line. Second calculate down to 5. I move the little Spider-Man guy near that point. I go enter, 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 and it looks to me like 1.17 seconds.